Alright, welcome back. In the last couple of lectures, we talked about the fundamentals of networks at the plant level. We've talked about some of the historical reasons as to why there are certain changes being made. Today, I wanted to look at some of the plant network requirements, as you can see by the title on my whiteboard, and the goal is to truly understand the why we're dealing with some of these challenges today more so than before. I also want to elaborate a little bit as to why this is an opportunity for the management side, why this is an opportunity for the engineers looking to gain some of this knowledge, and basically explain some of the conversations that I've been having with different manufacturers, with OEMs, with different hardware vendors, as to what is changing in the manufacturing space that is leading to the fact that you need to know OT networking more so now than before. So without any further delay, let's just briefly discuss the general history of the plant. And as I had mentioned, there were a lot of different protocols that allowed us to communicate to devices in order to expand the capability of our control systems, right? And in a nutshell, without getting into specifics, the control systems were basically designed to control something via a PLC, and of course I'm going to oversimplify this a little bit, an HMI, right? So this is going to be some kind of a user terminal. Again, if that has some buttons, that's going to be maybe a different part number than what you will see today, and it's going to have a bunch of remote I/O. It's going to have a bunch of VFDs. It's going to have some servo drives. So in a general sense, we had past private, I want to say, networks on, as I had mentioned, on ControlNet, on DeviceNet, that were not accessible necessarily by the rest of the plant. So if you wanted to get any of this information, if you wanted to remote into your PLC, that was going to be a separate connection, right? So you could connect via Ethernet for a number of years, but generally, you wouldn't be able to necessarily drill down into any of those devices outside by going through the backplane or through your control system. Now, as those devices have become obsolete and no longer supported, we are now looking to basically migrate a lot of those devices on the same protocols that we've seen in IT. And this starts to present a number of challenges in the OT space, including getting the hardware required to make that happen, right? So from unmanaged to managed switches. And I don't expect you to understand the differences, but what I'm telling you is that as we migrate from some of the older ways of doing things, we now need to have the knowledge of OT at this level for our networked equipment, right? So instead of connecting one thing, we're going to set up a switch. And again, I'm drawing lines. Obviously, this is going to be different connections, whether that's a star topology or maybe a ring topology, and we'll discuss that again in more detail in a later section. But the first point here is that we're migrating from older protocols that were very proprietary, did not allow us to extract any of the information or data directly from those components, to a network on Ethernet and Ethernet IP or Profinet that allows us to connect directly to those devices, right? And the question is, well, why would you want to do this? Your PLC can talk to those devices and you no longer should need to configure anything else once the system is commissioned. Well, the reality is a little bit more nuanced than that, right? So we're starting to see architectures where, for example, a different area might also want to communicate to this HMI, or maybe send a signal to the servo drive. You want to maybe pull more data into other different systems and have more control over the flow of data to and from those devices. So that's going to be the first point I wanted to make. Number two, we are experiencing what's called the fourth industrial revolution. And not to get into the buzzwords and sort of the higher level explanations of what that is, but in a nutshell, everyone is looking to get more data from the plant floor. And so in very, again, I want to say, as less details as I can, I'm going to draw the ISA stack, which many of you, I would assume, have seen. And so here you have your field devices, here you have your PLC and HMI. And I have multiple videos on this, so if you want some in-depth explanation, don't hesitate to take a look at those videos. SCADA, MES, and you're going to have ERP systems, right? And so the goal here is basically, or has been for many industries and many plants and many operations, is to start passing data upstream and of course pass certain data downstream, right? So this requires connectivity across the plants in order to be able to not only talk from, let's say, PLC to your MES, but also be able to send some field device data, for example, into your SCADA system, right? And obviously, the reverse can also be true. So this is also driving the reason for transforming and being better equipped when it comes to your OT network. It's extremely, extremely important because this now allows us to make decisions better. This also allows us to pass certain information back to the HMIs, let's say in the field, in terms of work orders, in terms of tracking your batching system. And so a lot of architectures that require those sort of processes will heavily rely on OT networking. The other item, and just as important, maybe we can leave this diagram on, is that we've seen a lot more Ethernet-based devices in the market, right? So the OEMs have recognized that there is a need to basically make data more available. So what we see now, instead of, I'll give you one example, so the Circos line. So if you worked with the Kinetix 6000 or 6200 series from Allen Bradley, usually you would have a PLC rack, and I've raised this just to make a little bit more space. You would then have a series or at least one Kinetix type of card. So I'm going to draw 2, 3 cards here, and you would have a fiber optic input as well as output on each card, which would then generate the signal for your Circos loop, right? And so basically the rack of Circos, depending on how many drives you have, you could obviously have blanks, but you had a number of drives that would be stacked together via a common power supply. And so the output of this card is going to go into module 1, then it's daisy chain 2, 3, obviously hitting as many cards as it needs, skipping the blanks, and then this would return back to the input of your Circos module. And so this way, right, so you would have basically servo drives on the other side. And again, I'm just making a very basic drawing of a couple of motors that you would have in the field. And so each one of these cards would then, in this specific case, the ones that I had worked with, would have 2 different cables, one for power and one for auxiliary for all the signals that it's sending. But you had absolutely no way besides of talking through the software on the PLC drawing some of those values. If you had an external system that wanted to check the health or the status of your drive, there's no way to get those packets, right? So basically whatever you've programmed on the PLC, if you're getting those parameters, if you're getting those values, you would then talk to the PLC directly and you'd be able to send them to the rest of the plant. Now, why the manufacturer has changed the scheme, and the new scheme with the different PowerFlexes has either became a rack over Ethernet IP or standalone VFDs, servo drives on Ethernet IP, is a complicated question, but basically you can achieve the same level of precision, if not more, by going via Ethernet IP to some of these components instead of using the fiber optic. Whether it's a question of cost, that is obviously up to debate, but the long story short is that the manufacturer now provides a way for you to put in a switch, again, managed or otherwise, that connects to your PLC, that connects to this rack, that connects to each one of these drives. And so you are able to, again, either to create a private network for that entire system, you're able to share some of that information to other systems, you're able to, and obviously it's not always recommended specifically with servo drives, but it's just an example, you can control them via 2 different PLCs, for example. Again, that's obviously not something you would like to do for a variety of reasons, but basically the point here is that we've migrated from this system that used to be on fiber optic that is now on Ethernet based protocols, and so you no longer have an option to know how to make this architecture happen that would make sense and allow your system to function at its optimal capacity. And this involves looking at the switch for the traffic that's currently there, looking at the PLC card that's also communicating some of that high-speed motion, understanding the differences between ring and star topologies, right? Assigning the IP addresses to these drives in a way that makes sense for either a private or a public schema. If you're bringing in a machine that's going to be isolated into your environment, or if you're going to have to move to a plant environment, again, depending on the requirements. So hopefully that example makes sense. The other example in the same type of a bucket or conversation is doing Ethernet-based safety, right? And so for many years, this has been taboo because Ethernet communication and networks are noticeable, or I want to say known for certain types of issues. If you have a bad OT network, you're going to experience downtime as a result of putting your safety devices on that specific network. But as the network architecture is improved, it actually is a lot easier then to wire in a lot of cabling for each specific safety device. And I'm not going to get into the costs of wiring and why it saves a lot of time, but basically you now have safety PLCs that can communicate over an Ethernet-based network to your field safety. So I'm going to call this safety, and this has all sorts of different requirements depending on the level of safety your system needs, but basically the network required to make sure that this operates correctly needs to be very robust, very reliable, because you have different handshakes happening between the PLC and the safety device, which will then have dual channel redundancy and some other features that you would not necessarily care for in the traditional sense. So now your network not only needs to support general devices that may respond in a longer period of time, now you have very deterministic safety that if the network is incorrectly set up, is going to basically cause downtime for your manufacturing operation. And so I hope that the point here is very clear in the fact that you need to, as the operator, as the end user, as the OT, or as the control systems engineer, you need to understand a lot of these concepts and be able to manage the network appropriately for your specific application. And so in this case, like I said, there's going to be a lot of different changes on the plant network requirement side, but depending on what you're looking to build, you no longer have the option of using some of those older protocols to completely isolate your system. You now need to know the fundamentals and at least some of the features of OT networking. So if you have any questions, again, don't hesitate to reach out, leave them in the comments, and we'll make sure to answer your questions promptly.